Part 2 of our KSP tutorial walkthrough. KSP2 to be specific. Let's get right into it, shall we? Missing the ground. This is our second learning session. First thing here is an animated tutorial which I watched with my local supporters the other day. Today we're going to start with stack decoupler and merging workspaces, and we'll make our way down these next 4. So 5 total. Here we go.
When you're making a rocket, it's often easiest to work top to bottom, tailoring each stage to carry the weight of everything above it. To give you a head start, I've already placed an upper stage, perfect for maneuvering in the vacuum of space. It could use another, more powerful stage to push it up to space from Kerbal's surface. Let's turn this vehicle into a multi-stage rocket. Anytime we intend to drop an empty stage after using all of its fuel, we connect it to the stage above it using a decoupler. A decoupler contains explosive bolts that, when activated by a staging action, eject the attached stage away from the rest of the vehicle. Add that decoupler to the bottom of your rocket. We need to attach a larger, more powerful lower stage to the bottom of your rocket. To keep things simple, I've whipped up a new lower stage in another workspace. You can bring saved vehicles and other sub-assemblies into an in-progress workspace by merging it. Let's merge my lower stage into this VAB workspace.
Let's do.
Out in the real world, this list would show all of your saved workspaces. Here in the simulator, I'm only showing you the lower stage you need to merge. Now that the lower stage has been merged into your current workspace, you can see it next to the upper stage. Select the lower stage and connect it to the decoupler beneath the upper stage to create a single 2-stage rocket. Perfect! Merging is a very powerful tool. Anytime you want to reuse a particular booster, lander, or other element from an existing rocket, merging saves you the hassle of making the same thing over and over.
It's actually really handy. I like that.
Space rockets sometimes need an extra boost. In a rare case of rocket scientists naming something well, these additional rocket engines are called boosters. Boosters are attached to the sides of a vehicle to keep them out of the way of the main engines. Solid fuel rockets make great boosters. They produce a very high thrust for a short time. Let's attach some boosters to the sides of your vehicle. We'll start by attaching 4 radial decouplers that will eject the spent boosters when they're empty. To make sure that these decouplers are evenly spaced and aligned with one another, you'll be using the symmetry tool.
Right-click the symmetry button in the toolbar. Select 4.
Great! Now when you place a part on one side of your rocket, 3 more evenly spaced duplicates will appear around the rocket. Go ahead and add 4 radial decouplers.
Same thing as pressing the X button as a shortcut.
Good. Now attach it as shown. Perfect. Now you've got 4 radial decouplers exactly where they need to be. Let's attach those solid fuel boosters. Since you're still in 4x symmetry mode, simply attach this booster to one of the decouplers you just placed. That will attach copies of that booster to the remaining decouplers. Great job! You've finished your orbital rocket. You can symmetrically place up to 8 parts at once, a feat that could until now only be achieved by certain sea creatures.
Haha.
Before you launch a rocket, you need to plan the order of your staging events. Nobody wants to start out their flight by popping their parachute, right? Most parts that can be staged are automatically assigned to stages. Their activation order can be seen in the staging stack. You can change when staging events occur by moving them between stages. You can also add, remove, and reorder stages. Best of all, you can do this in both the VAB and in flight. The staging order begins at the bottom of the staging stack. You want your boosters and main engine to fire together for maximum thrust. The solid fuel boosters are currently in the second stage. If we don't change anything, the boosters will ignite late and detach themselves at the same time. This would be embarrassing for everybody, so let's move the boosters down to stage 1. Your solid fuel boosters burn very hard and very fast, so they will run out of fuel first. Even though your main engine and boosters will activate at the same time, you want to drop the empty boosters before you drop your main engine. You'll add a new stage above stage 1 to do one thing. Activate the radial decouplers to jettison your spent boosters.
I think it's already set up that way, isn't it?
Now move all 4 radial decouplers from stage 4
Oh, no.
to your new stage 2.
I was looking at the core booster decoupler. There we go.
All done. Your remaining stages are set up so that stage 4 will activate your orbital stage's engine. Stage 5 will detach the orbital stage's fuel tank when it's empty. And stage 6 will deploy your landing parachute. Thanks to you, this rocket is ready to fly.
We are just flying through these. Eh-heh.
All right, we're ready to light this candle. In this flight, you're going all the way to orbit. I'll walk you
Nice.
through the process of launching, executing a gravity turn to get moving sideways, coasting to orbital altitude, and doing a final burn at the top of your arc to establish a stable orbit. Before we begin, let's talk about the nav ball. The nav ball shows your vehicle's orientation relative to the horizon. The blue half of the ball represents the sky, and the brown half represents the ground. The level indicator at the center shows your vehicle's orientation. When you turn, the ball turns. When you roll, the ball rolls. Assuming you want your rocket pointed at the sky, you'll want to see lots of blue on the nav ball. If you get confused, remember this rhyme. If the nav ball's brown, you're going down. At launch, you want all your engines at maximum thrust, which means you need to set your throttle at 100%. Your solid fuel boosters are way ahead of you on this. They have no setting other than full throttle, and they can't be shut off once they're lit. Once you hit the go button, they'll go full tilt until they run out of fuel. Still, your main engine's throttle is in your control. You can see your main throttle here. Left shift gradually increases your throttle. Left control gradually decreases your throttle. Z and X instantly set your throttle to 100 or 0% respectively. Left click on the throttle will set its level where you clicked. Your fuel levels are visible within the staging stack. Right now, you can see that your main engine and 4 boosters are all topped off and ready to rumble. It's time to go. At the start, all you need to do is fly straight up. I'll check back in with you once those boosters are empty. Good luck!
You hear that rumble? We're ready to rumble.
Solid fuel boosters are empty. Let's drop them.
Let's do it.
It's time to start your gravity turn. A gravity turn uses the pull of the planet's gravity to help bend your vertical ascent into a horizontal arc. It's the first step to entering orbit. For our first flight to orbit, we're going to start our gravity turn up to where the air is thin, at an altitude of around 10,000 meters. To show you where to aim your rocket, I've placed a target marker on your nav ball. First, we need to get to 10,000 meters.
They held on a little bit there. 9,000, 10,000.
You're going to yaw towards the east so that the target marker is in the center of the nav ball. Your vessel and nav ball should look like this example video if you're performing the gravity turn correctly.
It's struggling. Should put some fins on there, yo. Oh no. I'm trying, dude. It's struggling. We're out of propellant. Oh, almost got there. I think I'm gonna fail this one, guys. There we go.
We're out of fuel and simulated stranded. Let's try again.
I failed the tutorial. I suck. All right, let's try this again. Can't believe I failed a tutorial. I suck.
All right, the solid fuel. It's time to start your gravity turn. First, we need to get to. You're going to yaw towards the east so that the target marker is in the center
trying to
of the
yaw,
nav ball.
bro. I'm yawing.
Your vessel and nav ball should look like this example video if you're performing the gravity turn correctly.
Gotta get there, get there, get there. Yeah.
Way to make Kerbin's gravity work for you. You're now on track to establish an orbit.
I'm fighting it. I wonder if I could just cheat.
The current stage's fuel is empty. Let's drop it and activate your deep space engine. Great job! Your rocket is on its way to orbit. As you gain experience, you can make your gravity turns more efficient by starting to tilt your rocket soon after liftoff. Adjusting course with a series of small corrections instead of one big one will leave you with a lot more fuel when you get to orbit. Turning immediately after launch requires a very stable rocket, so if you ever have trouble keeping the pointy end up, you can try the simplified wait and turn method we use today. Right now, we're on a ballistic trajectory. If no further adjustments are made, your rocket will eventually fall back down to the ground. Our objective is to turn this arc into an orbit. The process of turning your trajectory into a circular orbit is called circularization. Partial credit to the rocket people on that one. It does have the word circle in it, but it's really hard to say.
I always had trouble saying circular when I was a kid. It was hard for me.
When planning and executing orbital maneuvers, you'll want to switch to map view, where you can see every part of your current trajectory. The blue arc passing through your vehicle is its current trajectory, the path your rocket will follow if you don't touch the controls anymore. Our goal is to make that arc into a circular orbit. After you've coasted nearly to the top of this arc, you're going to point forward, and then you're going to ignite your engine. If you time this burn right, you'll never quite get to the top of the arc, as it'll keep widening in front of you until it wraps all the way around the planet. Let's break that down a little more. The top of your arc has a helpful tag in map view. It's called the apoapsis, abbreviated as AP. You're going to max out your throttle before you pass this point. We're paused at just before the apoapsis. We want to go faster in the direction we're already moving, so we need to make sure our rocket is pointed forward. There's a handy marker on your nav ball called the prograde marker. That represents your forward direction. Use the Stability Assist System, or SAS, to point your vessel at that marker. You're all lined up and ready to go. The next step is to go max throttle. It can take time for your arc to fully expand into an orbit. If you look closely at where your trajectory meets the ground, you'll see it moving toward the horizon. Once your trajectory reaches all the way around the planet, you'll see another marker on your orbit. This is the periapsis, or PE, the lowest point in your orbit. It'll always live on the opposite side of your orbit from the apoapsis, or highest point. By burning prograde near your apoapsis, you increase the altitude of your periapsis, the lowest point on your orbit. Here's the most important thing to remember about setting up an orbit above an atmosphere. Your periapsis must be higher than the atmosphere, or your rocket will start to slow down every time it dips into the upper atmosphere. On Kerbin, that means every part of your orbit must be higher than 70 kilometers. Keep your eye on your trajectory for now. Okay, your orbit is fully out of the atmosphere. Cut the throttle. You did it! You're in orbit! This is when I'd usually tell you to look under your seat in the simulator, where you'd find a delicious celebratory treat. Sadly, since the vending machine in the astrodynamics lab broke down, it has gotten very difficult to hide snacks anywhere at KSC. Feel free to take a moment to admire your first orbit. In a way, you've given yourself a mind snack, which is way better than the edible kind anyway. Right? Right?
Bilemon Kerman. He's quite bald. How about that? I can appreciate the clean shave look. There's the Mun. We'll be going there very soon. Okay. Cool. And that's going to wrap this one up right there. Thank you guys so much for tuning in with Kerbal Astronaut Kev Kerman. I'm the Kev Kerman. Reserve that name. My what do the fire pilots have? The call sign. My call sign is Special K. Godspeed until the next one.